Hey everybody, just figured I would take a first attempt here at trying to explain some of the concepts that we're running into with the distance learning. I know this is new for all of us, so we'll figure it out together. So just remember, do the best you can, that's really what matters, and then communicate with me as much and as often as you need to. You can get me on the Remind app and right through Odyssey-ware. Okay, so with our first distance learning unit, Newton's laws, circular motion, and momentum. I'm going to talk about a couple things here, go through a couple problems together. And the first thing I want to point out is it might seem like new material, but really it's just building off of things that we've already talked about. So what's old becomes new. So we already know, obviously, Newton's second law of motion. We know F equals ma. If you have an unbalanced force, it'll cause some mass to accelerate. And then building off of other things that we've already learned, we know that if we have constant or average velocity scenarios, we know that we can analyze them with a super simple d equals vt. And then going back old school to some geometry stuff, we know a characteristic of a circle in terms of getting its circumference. We can use the equation circumference equals 2 pi times the radius. And going back to Newton's second law here with acceleration, we know acceleration really just describes the rate of change of velocity. So these concepts are kind of the foundation for what's coming up in this unit. So it might seem new, but it's really not. Okay, so let's take a look at a problem like this. If an object moves in uniform circular motion in a circle with a radius of 2 meters, and the object takes 5 seconds to complete 10 revolutions, what is the object's speed around the circle? All right, well, let's apply the problem-solving technique we already know. Let's identify what we're given. We know that the radius of this circle is 2 meters, and the time, it's expressed to us a little differently. It takes 5 seconds to complete 10 revolutions. So if we divide that out to get 1 revolution, it's 0.5 seconds per revolution, or that would also be called 0.5 hertz. And we're trying to find the object's speed. So in terms of our equation variables, we're looking for v. So this really goes back to that basic relationship of d equals vt. The distance around the circle, we have some of that information here. So if we rearrange this to isolate velocity, v equals d over t. Well, again, this is a circle. So when we're talking about the distance around a circle, we really are talking about circumference. So what we can do then is we can do a little substitution here for d. The distance around a circle is 2 pi times the radius over t. So here we have 2 pi times the radius of 2, and the time to travel that specific distance is 0.5 seconds. So we end up with 4 pi over 0.5, and if you work that out, you get that the speed around the circle is approximately 25.1 meters per second. Okay, we'll build off of this and go a little bit further here. Another scenario. An object moves in a uniform circular motion at 20 meters per second and takes 1.5 seconds to go halfway through its circular path. Calculate the object's centripetal acceleration. All right, so again, apply our problem-solving technique. Let's identify what we're given and what we're trying to find. We know that the speed or the velocity around the circle is 20 meters per second. And the time, we are given that it's 1.5 seconds to go halfway around the circle, or 0.5 revolutions. So if you think about that visually, to go halfway around is 1.5 seconds. So to continue that the rest of the way, this is equivalent to 3 seconds per revolution, or 3 hertz. And now we want to find, ultimately, centripetal acceleration. Okay, so in this unit, in the notes that you get from Odyssey-ware, you're given the equation centripetal acceleration equals velocity squared divided by the radius. And so if we look at this, we have a missing puzzle piece here. We don't know what the radius of this circular path is, so we've got to figure that out. Again, we can go back to our basic relationship for constant velocity, d equals vt. If we rearrange it for velocity, v equals d over t. And remember, the distance we're talking about, because it's a circle, is the circumference of a circle. So it's 2 pi times the radius. And here we know the time to complete one revolution is 3 seconds. So now what we have here, and we know our velocity. So now we have this equation, a velocity of 20 equals 2 pi times the radius divided by 3 time. So multiply both sides by 3. 2 pi times the radius equals 60. Divide both sides by the quantity of 2 pi. And on your calculator, make sure you do 60 divided by the quantity of 2 pi here. So what you'll end up with is that the radius of this circular path is about 9.55 meters. And again, that's not actually what we're looking for. That was just our missing puzzle piece to calculate centripetal acceleration. So now centripetal acceleration is v squared over r. Well, we already were given the velocity, so it's 20 squared over the radius that we just figured out of approximately, so let me update that, 9.55 meters. So when you work that out, the centripetal acceleration ends up being about 41.9 meters per second squared. There's that one. Moving on. Here's another scenario. A 40-kilogram child takes a ride on a Ferris wheel that rotates with a tangential speed of 1.2 meters per second. Find the centripetal force that maintains the circular motion of the child if the distance from the center of the Ferris wheel is 15 meters. So right off the bat, tangential speed, that can seem a little like, what the heck is that? Well, again, if you think about this is circular motion. So at any given time, as this kid's going around, you could identify their speed as being tangential to the circle at that moment. So that's really all that is. So it seems like it's some extra thing, but it's not. So again, problem-solving technique, identify what you're given. We know that the mass of this kid is 40 kilograms. We know that their speed around the circle is 1.2 meters per second, and that the radius of their circular path is 15 meters. So going back to Newton's second law, F equals ma. Well, here centripetal force equals mass times centripetal acceleration. So the centripetal force is m, and then acceleration centripetal is v squared over r. So we can do a little substitution right here. So F sub c equals mv squared over r. So we know the mass of this kid is 40 kilograms. Their velocity is 1.2 meters per second over the radius of 15. So when we work that out, the centripetal force ends up being about 3.84 newtons.